Good morning. How you guys doing today? Happy Wednesday. All right. So we have the first part of Java fundamentals. If you guys are following along at all at the slide deck or in the chapter, you notice this one's a little big. So don't worry. We'll take our time getting through it. It's like 96 slides on the slide deck, which is just intense, but that's okay. So we're not going to try and do it all in one day. We'll take 3 different sessions to get through this here, and we should have some fun with it. So we'll talk about project 1 today at the end as well. I think everyone so far, as of last night, who had project 0 in did great, which is awesome. We got our tools set up and running, and that's the first step. So if you haven't gotten your score on it yet, I should be getting to those pretty soon. This one I look at right away because I want to make sure everyone gets set up using Git and NetBeans and knows how to get code to me. So that's the important part. Okay, so we'll do Java fundamentals this week, or the rest of this week today, and then all the next week as well. And then after next week, we'll have the quiz for chapter 2. Good morning, people I'm definitely in a class with. Yeah. This pandemic learning stuff is weird. Really weird. Okay. So let's fire this up. Let's take a look at NetBeans here. And I'm going to open up my GitHub client. And we're going to talk about some Java code. Make sure I have the right repository here. 1500. Yeah, there we go. All right, so I always want to make sure I've got the right repository, and I know that when I put new projects in here, they're going to show up. Let's just make sure I don't have to move anything around or have any issues with that. And if you're ever working on more than one computer, you always want to make sure you do this little fetch thing first. GitHub's pretty good about telling you if there's changes, but this will just make sure that... Oh, sorry. Okay, good. Should probably mute my phone. All right. It'll make sure that we have all of the changes from the central repository reflected here locally. Again, it shouldn't matter much for you guys for what we're doing if you're ever only working on the one computer, but it's just a good habit to get into. Find the repository, do the fetch thing, make sure you're all up to date. And, it takes a while for NetBeans to load anyway, so. All right, awesome. So I'm going to start up a new project. Maybe. It's not even Monday, computer. Come on. There we go. Right, Java with Ant, Java application. A hat. Oh my goodness. I'll just wear my hood. That counts as a hat, right? There we go. That counts, right? So Java with Ant, Java application. I go next. And now I want to make sure it's in the GitHub repository folder. So this one is not the right folder. That's the wrong class. Right? So a couple things. You can do browse if you want to go browse for it. You can go to your GitHub client, go to repository, show in Explorer. This one's usually my favorite. Once you have it in the Explorer, you just click into this white space. It'll highlight the whole thing. You can do like Control-C for copy. Then back in NetBeans, I just paste it all in here. Just grab it all and paste. Or you can do browse, or you can, I don't recommend you type it. That's probably the slowest. So it's chapter 2, part 1. Okay. Oh, it's dry in here. This winter dryness is killing me. All right. So then we're all set to go. Go ahead and finish. And if we got the right location in our GitHub directory, we should see a bunch of new stuff pop up here in a second. All those project files. Sure, those are all great. We just go ahead and leave them alone. And then eventually we'll get that .java file. Just takes a minute. don't need that chapter 6 project. I can close that one down. All right, there's a Java file. Let's see if it shows up here. There it is. So chapter 2, part 1.java. Great. So if we see it all here, that's fantastic. You can make a commit now if you want. You can commit later. It's okay. Commits are free, so I always like to commit early and often. It is chapter 2, part 1, started project. And then it's going to make it a little easier to see the stuff that we do change as well. So if I commit, and then commit is just part 1. Right? That means I have the change on my local computer, but I want to make sure I get it out to github.com. Let's push to the origin, that central repository at github.com. And then if you're ever not sure if it's there or not, you go to repository, view on GitHub, and it'll launch the URL for your GitHub repository. Again, if you get that like 404 not found or whatever, the sad panda thing, make sure you're logged in, because not everyone stays logged into their browser. Oh, it's not a panda, it's this little octocat thing. If you get him, make sure you're logged in. You can check over here in the top right. But yeah, we did find it. Right, the link was good. Right, this is a little too low. Gotta be able to see here. And then we can navigate around, just like you guys did to turn in Project Zero, to go find that Java file. Your code's always going to be in this src, that's short for source. And we can find this here. We copy that URL, and we're good to go. Okay, so most everyone did great on Project Zero. I don't think everyone got it turned in yet, but I honestly haven't had a chance to look this morning. It's been a little crazy. That's okay. Today's a big day, so if you do have trouble with Project Zero, get in touch with me. Right? Reach out, let me know what's going on. I want everyone to finish that one and do it well, because this is the process we're going to be using all semester long. And then if you take my class next semester, all semester long that semester. And then if you have me in the fall, all semester long. So just want you to get used to it for sure. Okay? We're good so far. So again, you can take out these comments if you want. You can leave them alone. It's no big deal. And we'll talk a little bit more about what these things are actually in a minute. I keep calling them comments like you guys should know that. I apologize. So it's okay. We'll add our own later. I'm just going to delete them because we don't need them. So this here, and we were doing system.out.println. Let me open up that Karnak thing again. Just remind me not to log into anything, because that's dumb. Let's see. I think I had it in here, right? Karnak. Yeah, it's already unzipped, isn't it? Karnak. There we go. So you can see the keyboard shortcuts and stuff I'm doing. It's a cool idea, at least, right? Okay. So we have S out and then tab should complete it, or you can just type system.out.println and you get some quotes here. You can't submit anything to my repository. So this one here that we're using for the class, you guys don't have access to. So if you filled out that getting to know you form, you should have a repository that's named like this, plus your username. Your username here, whatever your username is. So I think I just made a repository for you last night. If you use that same username, JMW, you should have an email. So take a look. Or are you meaning like your own personal repository, like you went and made one for yourself? So I prefer you guys not use ones that you make for yourself, just because then you have to make it private and invite me and it's a bunch of other steps, and then the URLs aren't going to match, and I'm going to get confused easy. So for now, use the one I created for you, please. And if you don't see the link for that, let me know. I can get you set up. Okay, so this is like all we did here for Project Zero. And there's a couple things that happen here that we haven't really talked about and what it all means. And these are part of the Java fundamentals. So this thing up at the top where it says package, chapter 2.part1. Java's funny about structure and organization of files. So I'm going to, let's go take a peek. I need Karnak. I want repository show in Explorer. And I want to see the folder that it's in. So we can see this thing over here on the left is this project explorer you probably saw. So we've opened this up, that has all of our Java files there. But what we're going to do, I'm going to open up the project, and you'll see there's this source folder. So code goes inside a source, and then what's inside a source is more folders. You'll notice there's a folder named Chapter 2, and you see there's a Chapter 2 here in the package. And then there's another folder called Part 1. You'll see there's a folder called Part 1, and there's in the package .part 1. So the dot here is essentially meaning, hey, there's another folder. Inside of that, now we have a Java file, Chapter 2, Part 1.java. The class name matches the name of the Java file. This is a must. Java is very particular about this. Some other programming languages don't care so much, but Java does. Excuse me. So the package is essentially what folder it's inside of. Okay, so packages are just like folders. It's just a way of organizing stuff together. Later on, maybe, I think in Java 2, we might do some more interesting stuff with packages. But for now, we're really boring. So we're going to use packages. They're just folders that our code is inside of. And then this public class thing here. And the casing does matter. If I try to put a lowercase p here, it's going to complain, and NetBeans, anytime you get these red lines, it means NetBeans is mad at you. It's not mad at you. It's saying it doesn't understand something. So it's saying class chapter 2 part 1 is public should be declared in a file named chapter 2 part 1.java. So it's saying it doesn't match. Right? The file name doesn't match the class name. So I'm just going to undo that here. Okay, so we want the class name to match the file name. And for most of what we're going to do, we're only going to deal with one file. We'll get to having other files the second half of this semester, once we start talking about classes. So again, public class, and then the name of the Java file. And then we get these curly braces. Curly braces are fantastic. They are in charge of defining, the official term is scope. I like to say it's things that belong to this, is how I like to imagine it. So everything inside of the curly braces, from the start here to the bottom here, and you notice if I click next to one of them, it highlights the ending one, or if I click on the ending one, it highlights the beginning one. It's fantastic. So it's nice and easy to spot these things, and you even get this cool little by the line numbers, this little bracket thing. It's showing you, hey, here's where it is. Here's where it starts at line 3, here's where it ends at line 9. Okay, so it's saying everything inside of these curly braces belongs to the class chapter 2 part 1. Cool, it works out pretty well. Then we have this other thing, public static void main parentheses string square braces args end parenthesis. Whew. We used to have to memorize this and write it down, off the top of our head, or just have to go look it up. Thankfully, NetBeans will just give it to you. So public static void main string args is where every Java application ever, mostly, will start. For now, yes, until we learn more. So every one of our Java applications will start with main. So when the program runs, remember when we hit the run button, it's going to start at the main method here. This is called a method. Don't worry too much about that. We'll get there later. But it starts here. And everything inside of this set of curly braces now belongs to main. So we're going to be working inside this main set of curly braces. We okay so far? I think I can show you that. Let's see. I think we get that command output. If I run my hello world, see if it even works for me today. Nope. Okay. So if you hit run and you don't get a print because you think it should print, NetBeans is not being helpful. So come to project, right click on it, and go to properties. So this is in the project view on the left. Go to properties. There's a whole bunch of menu options. We want to go to the compiling option, and we uncheck compile on save. Because for some reason, it still won't compile. I don't know. I get confused easy. Okay. Now when I hit run, we should get some more action. There we go. Now it's actually doing something. That's good. Okay, so it is compiling. So remember when we picked Java with Ant, it does this Ant thing. So Ant's just it's called a build tool. It automates some tasks that are tedious for us. And some of those tasks that are tedious are doing all of these things that it's kind of spitting out here. So don't worry too much about it. But eventually what happens is it over here? No, that's okay. So remember we talked about the Java virtual machine last week? Man, last week was such a long time ago. I can't believe it. And this idea that Java is a compiled language, we get these cool looking class files in here. We took a peek at these class files, didn't we? So in build, and you notice build never shows up in GitHub. This idea, anything that you can generate, we don't need to keep a copy of in our source control tool. So by generate means I just have to open up the project and hit build or run. Chapter 2, part 1, and chapter 2. Yes, so the idea of what compiling does is it takes your human readable code and it turns it into a computer readable code in terms of a class file. And class files are nasty looking. So if we open this up with some kind of editor, so if it's not showing the print, you come over to the package name on the left, go to properties, go to compiling, and uncheck this compile on save. Go to the project properties, compiling menu, uncheck compile on save. For some reason, I don't know, it gets confused. I've yet to find a better workaround. Then it will actually compile it every time you hit run. Yes, that's okay. I'm going to open it anyway. So this is what that .class file looks like. Like some of this is plain text characters. We can see a couple things in here. I think, no, I don't see my hello world. Oh, there it is. Yep. Sometimes you can see the stuff you type in. Right. Oh, sorry. That's really small, isn't it? Let's see if I can zoom that. Oh, it's not a scroll wheel zoom. Sorry. It's just going to be small. But it's gibberish. It's nonsense to us because it's a machine readable file. So compiling our Java code takes our nice, pretty, Englishy looking code that's human readable and turns it into the machine readable class file. And then when we run it, the Java virtual machine will run the class file, and the Java virtual machine is responsible for talking to your hardware and the computer and the operating system. I guess really the operating system, and the operating system talks to the hardware, but to tell the operating system, hey, I need stuff to do this. Please do these commands. So we have all sorts of different Java virtual machines or Java runtime environments for all sorts of different devices. So Java runs on a lot of stuff. They used to advertise like some X billion number of devices, but I don't know if they do that anymore. And you notice the end of this command has a semicolon. So every command in Java, or statement in Java, I guess, you might call it a command or a statement, will have a semicolon. This is a header here, doesn't. This definition or declaration doesn't, but the package does. So not every line needs a semicolon, but just the statements of the commands, or even some of these package ones, get semicolons. Okay? You guys are doing good so far. Oops, that's not what I wanted. I wanted to come up here. There we go. So if we wanted to, I think we could probably do it by hand, but it's really tedious. I can find this class file. Let's try it, just for fun. Let's see if we can do it. I think last time I tried it didn't actually work for me, and it was a little embarrassing, but that's okay. So when we installed Java, we went and made this OpenDev folder, if you followed my example here. So I got my C drive, I have this OpenDev thing, and inside of here is where I put all my stuff. So in the JDK 15 folder, this is where all the Java good stuff is. So in the bin folder is where we want to find it. Inside of bin, there are a couple exe files. These are executable files. And if you don't see them, that's okay. You can go to View. You want file name extensions. Windows likes to hide them because they like to make things easy for normal people. So java.exe, that's the Java executable that will run class files. Java C is the Java compiler. You can point javac at a .java file, and it will compile it into class code, the .class file. Okay, so there's a bunch of cool stuff in here. Lots of other tools and things. We're not going to get into most of them, or any other ones really at this point. But what you should be able to do is go to this path here, I think. Let's try it. And if you run java.exe, again, I'm not actually typing most of this stuff. I type a couple letters and then tab, and it auto-completes, and then tab will pick the next one, and tab will pick the next one until I find the one I want. So that's why I like having this Karnak thing open, as long as I don't type in my password places. So java.exe and a dash question mark is like typically the help. Sometimes you get other things. You get all sorts of, woo, here's some stuff. So what you want to give it is the main class file, is typically our usual, what we want to run. We have to tell it where it is. That's a little bit obnoxious. Right? But that's okay, we can find Java there. So I'm actually going to go to my project instead. So let's go back here. We're doing an experiment. We'll see if this works. Years ago, we used to have people do this and like build a Java file in Notepad and then run the command to compile it and then run the command to run it. And I always thought that was silly. So I'll show you how to do it, but we have tools for a reason here. So, nope, not that one. I want the build one here. Okay, so I'm just going to copy that path, and I can go to that path, and I'll go to my build directory, and then classes inside of that, chapter 2, part 1. Sure. So inside of here, we can see that chapter 2, part 1.class file. Okay. I've used the command line a lot. I'm very familiar with it. I don't expect any of you guys to be familiar with it, so don't worry if you can't navigate around like I can. It's okay. You'll get there with some practice, but it's nothing you're going to need for this class. So don't freak out that I'm at this weird, crazy screen here. All right. So now I need to find the Java executable, and I don't have .java on my path. Right. I tab and it doesn't autocomplete. That's okay. Oh, okay. There, we'll clear that up. So I need to go C:\opendev / the JDK folder, bin java.exe. Oh, I didn't do enough. Sometimes there's too many of those. Java.exe. Okay, and then I give it chapter 2, part 1, because that's the main class file here, the main class. Okay, I'm not doing anything with modules, not doing anything with that. Yep, sure. So I don't tell it .class. Oh, couldn't load it. Isn't it chapter 2, part 1? That's what it's called, right? Chapter 2, part 1. So this is what I did last. It wasn't cooperating with me last time. I shouldn't have bothered trying again, but it's fun to try. It's always good to try. Find and load main class. 2, part 1. I wonder if the name's wrong. Chapter 2, part 1. Chapter 2, part 1. That's okay. I'm messing something up. This is why we don't do it by hand, right? Because this is just obnoxious. And these errors are not super helpful. Maybe class not found. One more try. One more try. Oops, exe. And then let's do chapter 2, part 1. Nope. Nope. That's okay. So C:, documents, users. That's not going to do it. Okay, no, I give up. It's not even worth it. It would have been cool, but that's okay. Don't even worry about it. All right. Well, that was a lot of fun for nothing. That's okay. Project files. Cool. Cool. So this is why we don't do it by hand, because it's just terrible. Yeah, compiled it all. Okay, it's gonna bother me that it didn't work, but that's okay. It's not all that important. You guys were thoroughly impressed anyway, right? No. Okay, that's all right. We can't make simple things work. A comment. Let's see. Let's talk about a comment. So a comment in Java is typically a single line comment is // This is a comment line. So anything that comes after a // is going to get ignored by the Java compiler. So comments are purely for people. It's a note that you leave yourself in your code or that you're leaving someone else in your code. Or there's some other cool stuff called Javadoc that I will trust you guys can get to work if you need to later. But I think I told you the story about how I got a point taken off for my project because I didn't leave a comment, but the project did all the things the project was supposed to do, and I was really sad about that. So I swore at that point in time that I would never take points off for not having comments. And I've kept that promise. I don't require comments. Some people like them, and that's okay. If you like it, go for it. I am very biased against comments, which makes me unique among faculty here, and that's okay. Right? We're allowed to have different opinions. That's part of the fun. It's my general rule of thumb, and what we'd like to imagine happens in the industry, and I know it's not perfect, is that if you have to leave a comment to tell you what your code is doing, your code's not very clear. And we'd like to say, hey, make your code better or more clear, rather than add more comments. And that's not always the case. So sometimes we need comments, and that's okay. And the Javadoc comments are super helpful if you're doing anything, if you're writing code that other people are going to use. It's very helpful. But again, we just don't need to spend the time on it here, and I'm not going to require comments. You might have saw some multi-line comments. That's /*, and automatically NetBeans put in the //. Anything inside of here is a comment. This is a comment block or a multi-line comment. So everything in here gets ignored. Okay, the /** is the Javadoc comment. So this here is telling Java, hey, this is Java documentation, and you've got some cool auto creation tools that will read this and spit out some cool stuff, and it's fun, but that's okay. You don't need to worry too much about it. Okay, but if you see it, that's what it is. So those are all comments. They can all get ignored. All right, Java is very case sensitive, right? Not only with this class name stuff, but with other things like print line. If I were to try and print a capital P, I'm going to get that lovely red line. And now, not all of these red lines are very helpful. Some of them are, and some of them are not. So in this case, the error it says is cannot find symbol. Symbol is method println given a string. Location variable out of type print stream. It's not super helpful, but what it's saying, if it can't find it, it means it doesn't recognize it. It doesn't know what one of these things is. Now we know, because we just changed it, that it should be a lowercase p, and then it'll be fine. But it doesn't tell you that. It's not quite that smart. And it's the same with system. If you try a lowercase s system, you get a red line. Package system does not exist. Right? That's a capital S for system here. So it's very particular about casing. Okay? It's a little bit obnoxious, but you'll get used to it. It just takes some time. All of our braces and parentheses and square braces need to match. And that means if you start a parenthesis, you need to have a closing parenthesis. If you start a curly brace, you need to have a closing curly brace. If you start a square brace, you need to have a closing square brace. So that's usually what I'll call them. So the parentheses, square braces, and curly braces. Okay, so all those are very particular. They all have to match. So that's what we'll call part of our syntax. That's the rules of the language. We got to follow the syntax to make sure it works. Same with quotation marks. If you start a quotation mark, you have to end a quotation mark. And we always use full quotation marks. We don't use the single apostrophe marks when we're dealing with strings. Later on, when we get to characters, I'll show you the single apostrophe and what we use that for, but that's okay for now. Okay. Cool. You guys are doing good. This out here, right? That's our standard output. That's all this lovely console-based stuff here. Now, we don't see it in another window because we're using better tools, but it's all printing out here. This is our console output. There's also a console input or standard input, which defaults to our keyboard. We can type stuff in at this line, and then we can get some information from users, which is fantastic. So a program that just does stuff and there's no interactivity, they can be useful, but it's not as useful to people. And then it's hard to make it do things that you want it to do. That's only going to do its one set of commands. So we're going to use some user input in a little bit to get some information from users and do something with it. So the Java language has a really cool library of functions and all sorts of things that it already knows how to do. We'll call it the API, or its Application Programming Interface. So the Java API does all sorts of cool stuff and has all sorts of built-in things. And we can even go find it. So if you look like Java API, and we're on version 15, sure. Let's see what we get. Here we go. docs.oracle.com/en English Java Java SE 15 docs API. It's big and long and looks scary. But this is what it is. This is the Java API. This sort of website is actually what the Javadoc itself will generate if you have those documentation comments, which is cool. So there's all sorts of cool stuff here that we can do in Java built in. It's a lot of stuff. So we don't need most of these things, but if you ever wanted to do some stuff, like we can go look at, this is all built in here. So that's like the Javadoc itself, networking, which is fun. You can do a lot of cool networking stuff. Let's look at our base here. Here we go. So inside of base is a bunch of other things we can do, like java.math is a cool library. So math has a bunch of stuff you can do in Java already. So sure, we've got some other classes we can look at. So you can kind of like click around and see some more information about these and what they do. And this all looks crazy right now because we haven't really got too much of it, but it's all out here that you can do cool stuff with Java. Let's see, what else we have? What else might be interesting? Util. Here, we're going to use this one in just a second. Here we go. So we're going to use this scanner class in just a second here. So if we wanted to know more about it, we could come to this page and read. It tells us all sorts of cool things, which is mostly gibberish for us now, but it even gives you some examples. It lets you read a number from system in. Let me zoom that in a little bit here. So scanner something equals new scanner system in int I equals sc.nextInt. Oh, we can read some integers from system in. That's the standard input. We can do some cool stuff with it. We can read, don't worry about this delimiter stuff. That's no fun. Use regular expressions. Those are fun too. But so all sorts of crazy things that we can do here, and it tells you all about it. Things that you can do with it. Got all sorts of commands. So the API is fantastic. Lots of detail, lots of information about Java. Sometimes it can hurt your head. Okay, so we don't often go out here, but you can go out here for more details if you want. Okay, so let's actually go use that scanner thing. So we're going to say scanner. Mr. Gaddis likes to call it keyboard because that's usually what we're going to use it for. Scanner keyboard equals a new scanner, and then in parentheses we say system.in. This looks crazy, and that's okay. And we get red lines because Java says, oh, I can't find symbol scanner. But now NetBeans comes to the rescue, and NetBeans gives this little light bulb up here. And you click on the light bulb, it says, hey, do you want to add an import for java.util.scanner? Yes, we do. We don't want these other options. These other options are not helpful. Don't touch the other things. But adding an import is great. Import says, hey, Java, you know you've got that utility library? I want that thing called scanner that you were just telling me about. So this is telling Java that we want to use part of its library. Now, the reason we have to do this specifically is so that the compiling process is faster. Right? If we didn't have these imports and our compiler had to go look at the entire Java library, there's a bunch of stuff out there. So we make it easy for the compiler and we say, hey, I want this one out of the library. So anytime we use something out of the Java library, we're going to import it to make the compiler say, oh yeah, that one. I know how to go find that one. We'll make that one easy. Okay. So scanner keyboard equals new scanner system.in. Awesome. So now we can get some input from the user. Now I'm going to do everything in strings for right now. A string is just a bunch of characters. That'll make life a little bit easier. So we're going to do a bunch of characters. Let's see. Print. That's good so far. Yep, okay. You're doing good. Some other fun things. We'll get to this in just a second. I want to make sure we're not getting too far out. You can also print line. So every time we use print line, this is another line. We go down a line. So it, behind the scenes for us, knows to go down to the next line. We've got different options if you don't want to go down to the next line. So when you just type in scanner here, NetBeans gives you a red line and says, oh, it doesn't know what it is, and the light bulb says, hey, do you want to import? You just click on the light bulb and say, yeah, you want to add an import. Or you're welcome to just type this line in by hand. You can just type import java.util.scanner with a capital S up at the top, and it'll do it for you. Or it'll do the import. You don't necessarily have to use the tool to do it. I just prefer not to type if I don't have to. I like when the tool does the work for me. So if you don't like stuff on another line, we can use system.out.print. And print here, now we can just say, hi, I'm a print command. And then we can do this again. So I'm just going to copy paste that in here and say, I'm another print command. And if we don't use the print ln, all print does is it's going to run everything together on one big line, because we're not printing new lines. So when it runs here, they all get smushed together onto a single line here. So sometimes that's good, because that's what you want. Sometimes you don't want that. The weird thing is, if you want new lines, you can put them in yourself. So there's a set of special commands or characters that you can use. They're called escape characters or escape sequences to tell Java, hey, I really want a special thing here. And most of them are pretty silly, but you can. So they all start with backslash. So backslash is a special character that Java says, oh, you want to do something special. And something like backslash n for new line will put in a new line. So print ln is doing that for us. It's printing this and adding the new line for us automatically. You can add them by hand if you want to be fancy. I'm not a fan of doing things this way because it's just more work for me. But now it goes down another line. So backslash n is the new line character. Like the enter key, like goes down a line usually, that adds a new line. We can do that manually. So it's backslash n is the new line character. So it's fun. So backslash n I'm not a big fan of because it's tedious, but cool. You can do cool things like backslash t for tab. I mean, when I hit tab, you can get tabs in there, but sometimes it does funny things. You know, like it tabbed this whole line in. Sure. So backslash t for tab, we'll put a tab in there. That's the tab literal or the escape sequence for tab. And then when it prints out, it'll be spaced out because it'll put a tab in there for me, which is kind of fun. So it's out there. Now, if we wanted to say, I'm just going to do it in a print line here because we'll do more backslash n's. And this is all in the book. You don't have to memorize it. Just there's a table in the book to look these things up. Say if I wanted to put or say like, hi, said Eric. Notice I'm getting red lines. Like it's hard to put quotes inside of an output because it thinks, oh, you ended your sequence of characters, your string here. So what we do is we backslash quote. So a backslash quote will actually print the quote mark, but it knows, hey, don't end this sequence of characters. Don't end this string. Make Java happy. So you can print, probably shouldn't be lowercase. We'll say happy Wednesday. Happy Wednesday. Okay, we'll give this one a run. So now we'll get quotes in the output here without screwing this up. So backslash quote. Then backslash is the one over the enter key. Okay. You okay with that so far? Again, there's all sorts of cool things you can do. The book gives you some fun examples. Oops, keep going to the wrong thing, sorry. Trying to sort of follow along here. Yep. All right. The next thing that we can do. So this is interesting and all, but all we've done is a bunch of print commands. We want to talk about variables in Java. So variables is our technical term for it. And all a variable is a place to store some information. So, and what's cool about variables is we get to pick their names, which is great. So programmers get to pick names for variables. And I'm going to say that we should always pick nice, meaningful names. Okay, so I might have a variable, just a string called name. So string is the type that I'm going to be storing. Strings are just a bunch of text. We're going to use strings all the time, so get used to calling them strings. String is just a string of text, a string of characters. So what we do is we say the type, and we say our variable name for it. So my name for this here is name. And we'll put it my name, why not? My name. And typically what we do for naming here, our convention, is something called camel casing. So the first letter is always lowercase, and then if you have more than one word, we can't have spaces. It can't be my space name. My space name. Do you guys even remember MySpace? Was that even a thing? So we can't have spaces. So to differentiate the different words, we capitalize the first letter of every next word. So it's like the humps in a camel. That's why we call it camel casing. Maybe let's say my first name, right? So each new word gets a new capital letter so that you can kind of at a glance see, hey, this is what it is. And then we'll say it equals. So this is not actually an equals. It is an equal sign, but it doesn't mean equals. This here is an operator. We'll call it the assignment operator for your technical term here. We're going to say, hey, take the thing that's over here on the right and assign it to the variable on the left. So I'll say my first name equals Eric, and then this is a statement or a command. It needs a semicolon. Okay, so that's in quotes. This is a string here. So now I have my first name as a variable, and what I can do here inside of system.out.println, instead of putting something in quote marks, and this is where it gets confusing because we use quote marks when we're telling it exactly what text to print. We're giving it strings. If I wanted to print the contents of a variable, and what is that variable storing, I just say my first name. And again, I just typed my, and it came up with, hey, do you want this thing called my first name? And I hit tab because yes, I want that one. I like to do very little typing if I can help it. Right, I'm going to let the tool do the work for me. Cool. Sorry, my sugar monitor here is being really weird. It's like turned off in the middle of the night and still won't give me back any data, which is weird. I don't know why it does that. Yeah, still signal lost. Come on, that's all right. So it'll print what is stored by this variable name. Remember, a variable is just a place to store things. So in this case, we're storing the string. So the book has some good pictures. What happens is Java tells the operating system, hey, I need some place in memory to go store this thing. Remember, memory is our fast storage, our RAM. That's the quick place to put things. But if we lose power, we're going to lose anything that's in RAM. So it's quick storage. It's not the long-term secondary storage where it actually gets written out and is resistant to power outages. But that's okay. We only need this while the program's running. So what we get here is a variable, which is a place in memory to store some information. Okay, so that's type of string. So it's the type, the variable name. We're going to assign it the value of whatever's over here on the right. Okay, and we can make another one. I can have a string, my last name. It's double quotes here. There we go, Charneski. And I could print my last name. So again, not inside of quotes. because I'm saying, hey, I want the contents of that variable. There's a light bulb. Yeah, the light bulb is not always helpful. This split here, don't worry about that. And this var type, well, we try and discourage that, at least in this class, because it's better to be explicit. Var is some kind of magic Java does, so don't worry too much about it. We'll get there. That splitting the declaration means if you want, you can take 2 lines instead of 1. You can say, hey, I want a string, and then I want to assign it a value. First name. This is perfectly fine too. So some people will declare a value here, like my first name. Java, I'm going to store a string. I'm going to call it my first name. Get ready for me. Then, and it doesn't even have to be here. It could be later. We could do it down here. Right? It doesn't have to be the very next line. Somewhere later, we can then assign a value to that variable. This is declaring the variable, and then assigning the value to the variable, or all at once. So either way is perfectly fine. Not a big deal. We can do either. Oh, that gets a little bit silly there as I'm typing a lot. Sorry. It's cool to see the shortcuts, I think, though. So maybe. Oof, wow. All right, so we're going to need some insulin here in a minute. So either one is okay. And then we use those variables by name here. So that's why the names are important, because later in your code, you're going to use the variable by name. Okay? Cool. You guys are doing great so far. We're getting there. Other things we can do. If I don't want Eric and then Chernesky on different lines, I want them all on one line, we can do a funny thing with strings, is you can add them together. So I'm just going to cut that out. Now, this is not really adding. It's the plus sign. But what we're doing here, when you deal with strings, it's called concatenation. That's our technical term for it. It's taking one and the other and sticking them together. Because it's concatenating them. It's just putting them together into a single string. So I can say my first name plus my last name, and it gets all stuck together. So if I want a space in there, I need to put in my own space. And I can concatenate my first name plus a space plus my last name. If I smush all 3 of those things together, now it'll look a little bit nicer. Or I could even say, like, hi there. So if you're doing concatenation, you got to make sure you're putting spaces in yourself. So hi there, space, and then a space between first and last name. And now I get, hi there, Eric Chernesky, all on one single output line, because I have one print line command. So that's concatenating. Now, sometimes that's useful because Java is dumb, and if we have some really long line of text and blah, 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 it's typically considered bad form when you're coding if your code goes so far on the screen that you have to scroll. Now, I'm zoomed in a little bit, so this is probably long enough for most people, right? Like at a regular zoom level or font size, this is probably okay. But if you have to scroll to the right, it's considered bad form. Java doesn't care, but other developers, other programmers, I will care if I have to grade your stuff and I have to scroll. It'll just make me sad, because it's more work that I don't want to have to do to see what your code is. I don't want to have to grab my mouse and scroll to the right and then come on back. That's just irritating. So that's why you'll notice there's a slight gray bar here on the right. That's the typical cutoff location. Again, it's just a convention. There's no hard rule against it, but I'm going to strongly recommend you do it. Now the problem is, if I come down, notice NetBeans is nice and friendly. It ended the quote, added the concatenation, started the quote for me automatically. NetBeans is super, super friendly. But what you can't do is just start a quote and try and end it on another line, because Java is stupid. Java doesn't understand this, right? So you have to, on every line, end the quote, and on the next line, start a new one. So if I want to do more here, I can't just put in a quote mark here. Please remember to start a new quote on every line, or a new string quote, or string on every line. Oops. Well, a couple things, right? My parenthesis here ended already, so Java stopped looking for stuff here. So I got to get rid of the parenthesis, I got to get rid of the semicolon so that it knows to keep going, and then I get a red line on the wrong line, because it says, oh, it expected a closing parenthesis. The reason it expected that is I didn't have the plus mark down here. Oh, and now it's still saying expected a closing parenthesis. That's true. It wants that at the end here. There we go. Closing parenthesis. So remember, every time you open a parenthesis, you have to end it when we're done with it. Here's some more text on another line. But now what happens when we print this one line out? Are we going to get all these new lines in between? No, Java is going to print all of this on one line, because that's what we asked it to do. So some really long line of text. Here's another line. And remember to start a new quote on every line. It's one big long line, because that's what we told it to do. We told it all in a single print command, please do this thing. So just some quirks, just some things to be aware of. So it will do exactly what you tell it to do, but sometimes remembering what we want to tell it to do can be a little confusing here. Yeah, concatenation, sure, cool. We can put in other stuff when we concatenate if you wanted. So we could, let's see. Yeah, that's fine. So here you could just put in like plus 42. And it will know to turn 42 into a string when it does concatenation. Java is sometimes smart and says, oh, it's a number, so it's not quote 42, it's not a string 42, it's the number 42, or I could say like 6 times 7 with the multiplication operator. And it's going to try and multiply those together, give me the 42 number, concatenate it in. I don't recommend you do that, because that just gets confusing. But you can if you want to, because sure, why not? So here we get our 42. Right, so it will evaluate 6 times 7. Now if you do 6 plus 7, you're going to confuse Java. So now we get 67. Because it says, oh, you want to concatenate 6 with this string. Oh, you want to concatenate 7 with this string. Sure, here's a 6, here's a 7. Not 6 plus 7. If you want 6 plus 7 to happen arithmetically, we put it in parentheses. We force the order of operations. This, please excuse my dear Aunt Sally, still applies to Java. Now we get 13. Okay, so just remember, and this is why I don't recommend you do it inside of print lines, because it's just awkward, right? Okay, we have better ways to do it we'll talk about in just a minute. All right, I think we're due for a break. Let me pull up some more music here. When we come back in, say, about 10 minutes, and we'll pick it up from there. You guys are doing great. We are cruising, actually, through the slides. We're almost a third of the way done, which is awesome. I want to get to using the scanner thing here in a minute. So I think this one's a fun one. Let's try this music. Oh, yeah, sounds like Mario. At least, you know, sure. All right, we'll come back in a couple minutes here. Just click in here to change my text. Let's do, say, 11:08 a.m. Why not? Nice, easy times. Okay, we'll be back in a minute. Hey guys, welcome back. All right, so we are cruising along here. Hope you guys got your coffee refill or your energy drink or whatever. So a couple rules about these identifiers or variable names. I like variable names called identifiers, sure. Again, Java is particular about things, so casing is important, but naming as well. You're allowed to use letters, you can use numbers, the digits, you can use an underscore, and even the $sign. I don't see that one as often here, but your first character can't be a digit. So that's the rules for what we can pick. Other than that, you want them to be nice and meaningful and descriptive of what they are. So a variable name like string ln for last name would be terrible. Oh, you should spell string right too. Tarneski. Just don't do that. ln is meaningless. Like, no one knows what ln means. You're not saving yourself any time here. Okay? So use meaningful, full descriptive variable names. Right? It is possible to get too long, like if it takes up the entire page, but other than that, you want to be descriptive and things. So, and don't use acronyms, don't use letters for things, like to spell things out is always a good rule of thumb. Okay, because you want to know what it is just by looking at the name for it. A couple things we can't use are anything that shows up in orange. Really, these are like reserved words that have special meaning in Java. We can't use those as variable names because it'll get Java confused, and Java gets confused easily, unfortunately. Okay. So the idea with our variable names is that we are self-documenting. You don't need to leave a comment and say, this variable is for my last name, when you can say the variable is last name. All of our variable names start with lowercase. Class names, you'll notice, start with an uppercase letter. We'll get more to that later. Don't worry too much about it. And then types of data that we can store. Some interesting types. So far we've done strings. You can also store numeric data. So we could have something like an int is short for integer. So int means integer, so a whole number. This is like favorite number is 42. And we do the same thing. It's the type of variable, the name for the variable, assigning it a value. And you could declare it once and then assign it later. Sure, doesn't matter. Or you could do it all in one line. That's okay. Now the other thing is you can change it. You can say favorite number equals, maybe if I decided I didn't want it to be 42, maybe we want it to be 77. I can change it, so I can assign it again. You can assign new values to variables all you want, but a variable can only have a single value at one time. So at any given point in time, it'll store whatever value, You can change it, but you can't store more than one in a variable until we get to chapter 7. But that's fine. Okay? So we can change the values here, which is cool. So ints are for integers. There are lots of numeric types. And my typical rule of thumb is this is our first programming class. We're not going to care about those other types. So we're only going to use int for whole numbers. It is possible an int is not large enough. An int can only hold up to the number 2 point something billion as its maximum value and negative 2 point something billion as its lowest value. But I don't think we're going to work with any numbers bigger or smaller than that, so we should be fine for now. So integer does have limits, but we'll be okay. And the reason is because it is stored, remember everything is stored as a byte, with individual bits of ones and zeros in binary. If we go to our little programmer calculator, we can go over to the binary, and we want to do the binary bit flipping option here, which is fun. So a single byte here, right, is 8 bits. Another single byte is 8 bits. That's right, my decimal equivalent. So that's 32,000 here. So with 2 bytes. With 3 bytes, I can store up to 8 million, right, as my decimal equivalent. And with 4 bytes, I can store up to 2,147,483,648. Now the problem is, when we use 4 bytes of information for an integer, we also need to know if it's positive or negative. So really we get I think it's the first bit is the signing bit. It's not all that important to tell positive or negative, and then all of the other ones make up the actual numeric value. So we can store one less than this. Remember, like the sum of the previous bits all added up is 1 less than the next. So this is 8. So the sum of all of these, we get 7, and so on. So if I turn them all on here, which is a lot of clicking, we'll get 1 less than that 2 billion number I just read out. And this is so important. We have to do it right. We committed. So 2,147,483,647 is the maximum value we can store in an integer. And I'm pretty sure if we Google Java max int, it will tell us that same number. Let's take a look. Come on, Google, or Bing. Work with us. There we go. I just want the number. Just tell me what the number is. Why is it not telling me the number? Stack Overflow, maybe? Yeah, there we go. Yeah, 470. 647. Texas? I've never lived in Texas. I've been there once for my daughter's surgery. We drove from Michigan to Texas, road tripped it down there, and she had her surgery, and then a couple days later we came back. We went in January, and it was like 50-something degrees, and everyone in Texas was wearing coats, and all of my kids were wearing t-shirts. We're like, 50 degrees is so warm, because it was January. All right, so that's an int value. Integers are whole numbers. The other thing you might want is something called a double. Double, all sorts of fun reasons. It's double essentially means a number with a decimal. There's other details and precision levels and whatnot, but it means we can store a decimal. So this is number with decimal, and I don't know, how about like 1.23? Oops. So integers are whole numbers. They can't have decimals because it's not a whole number. So if we're using decimals, we're going to be using doubles. Okay. There are other numbers that you can use in Java that hold decimals. One in particular is called a float. A floating point number is a number with a decimal as well. The reason why I don't like floats is because they're annoying. So if I just say, hey, like 1.23 as a number, this is automatically a double. Because Java says, oh, you have a decimal, you want a double. If you want it to be a float, you have to put an F here. for it to know that it's a float. I have no idea why. I'm sure there's reasons, and okay, they're all fine and good. But I like defaults. So if I put in this and it gives me a double, I'm going to store it as a double. I don't have to put an F in to get floats. If you need floats, you can put your F in your numbers. That's okay. Excuse me. Okay, so a couple different types. You can use all sorts of fun ones like that. Floats and doubles, yada, yada, yada. We'll get through that. You can use E notation if you want. Sure, it always confuses me, but that's okay. A Boolean type is really cool. That's a fun type. So Boolean, are you hungry, can either be true or false. So true or false is a Boolean. So Boolean is just a bit, essentially. It's either on or off. It's true or it's false. Okay? I started eating some breakfast over break, but I didn't get to finish it yet. That's okay. I'm still hungry. So Booleans are fun as a type. We can use those. And characters. And I think we'll stop at characters because we are cruising. We don't need to go too much farther. So then the character data type is called char. Char. This is a single letter equals, and now this gets apostrophes, not quotes. So apostrophe or single quotes here. So I might put E as a single letter. So these are different types. So it's always type, variable name, and then you can assign it a value if you want at that time. Okay, so that's working through some different types. You guys are doing great. There's a cool thing that happens with characters we'll look at when we probably finish up after. I don't want to go too far. We can get to more of this later. I think we're pretty good. I wanted to do scanner. Yeah, why not? We'll jump into scanner stuff for fun. So this is so we can get some keyboard input here. So all this is just having some fun with variable names. If you actually want to interact with your user and get some information from them, like we'll be doing on our first project, we're going to do it here. So we're not going to have quite enough info to start. That's a bummer. You know, we might need to wait till Tuesday for the first project, project 1, because we haven't gotten to everything yet, and we've already done a lot. I don't want you to forget all the other stuff we've done. Is that okay if we wait a little bit? Let's push it out till next week. Then we can talk about it on Monday. Or we can, I don't know. We do have a little bit more time. I feel like we've gone far already. Here, let me run a poll. Let me ask you guys in the audience. Well, you showed up, you get to answer the question. What should we, for the day? And do project 1 next week. Yes, no, keep going, but still the project. Oh, so those are getting too long, aren't they? All right, so just 2 options. Yes or no? What do you guys think? So I'll leave it up to you guys if this was enough. I know it's a lot of information coming at you with this concatenation and quotes and different types. So I don't want to necessarily rush through it. That's why we plan to have 3 different sessions on this chapter. And we're about halfway through it already, but the scanner stuff is going to take a lot of practice. We're going to spend a lot of time on scanner. And we're going to need to use this scanner thing for project 1. So we can either stop, call it a day, or we could push forward and keep on going. I just want to, I don't want to throw too much at you in a single day. And then I believe we still have a study group after a meeting at noon as well. So we'll have a little bit of time to get some food before study group. All right, so what are the votes? View the results. We had 5 people vote for yes, we should stop for the day, push project 1 off for next week, and 3 people vote no. So I think that means the ayes have it. That's what they'd say in England, right? Whenever you watch their parliament sessions. Because you guys do that for fun, right? Color is Dodger blue. Oh, yeah. that a specific shade of blue? All right. So I think we'll call it good for now. Let me make sure I've got all my code out here in GitHub. So this is more type examples. I'll push that out there. We'll come back on Monday then. We should be able to finish up most of the chapter and start talking about scanner, and then we can talk about what the first project is going to be. So it'll need some user input, and we'll do some basic arithmetic stuff with it. We just haven't had a chance to get to yet. That way we're not rushing through it. If we rush through it, we're going to forget things. You don't want to just cram this stuff. So I don't expect you to memorize any of it, but just know where you need to go to look up how it's going to work. So you should be able to print things out by now, declare some variable names, print those back out. Okay, we haven't really done a lot with the numbers of these other values, just there are other types than just strings. We'll get to all the arithmetic stuff on Monday then, because we're going to need to do arithmetic for our first project. We should be able to have a lot of fun. So at the end of next week, I'll post the quiz for Chapter 2. And if you've been attending SI sessions, you'll be able to get a bonus point on that. I'll make sure I get that list from our awesome supplemental instructor. And we can go from there. Any other questions, folks? I know I heard there's this like thing happening later today that's supposed to be, in the news, and some guy's giving a speech, some lady's giving a speech. So stuff is happening today. Maybe we can pay attention to that instead of working on a project. It's historic, right? Okay, I'm just stalling for questions now. I didn't tell you guys a dad joke yet, though, did I? I think I owe you one of those. Let's see. Find one of those, and then we'll call it a day. So last night, when we were sitting down for dinner, I still like to drink milk. I don't know, some adults apparently don't drink milk anymore, but I always loved it as a kid, and I think it's delicious, so I like to drink milk. But I was sitting there with my big cup of milk, and I always drank skim milk as a kid, for whatever reason. That's the kind we always drank as kids. So I prefer the taste of that, but we have to get whole milk for my kids who drink the milk, because they need the fat as their bodies are growing and stuff, and I don't need it, because I have my own issues, but that's okay. But I was sitting there with my big glass of whole milk, and I was just thinking to myself, this could be butter. No, it wasn't too bad, right? That was a decent one. I need to keep like a ranking list of the best dad jokes, so I know which ones to pull out of the rotation. Only the best material for you guys. All right, well, if we don't have anything else, we'll call it quits a little bit early today. Don't forget, you've got the study session today at noon, I think it's still happening. And we can go from there. So I'll work on getting those quizzes graded. If you haven't done the syllabus quiz yet, please get that in. If you forgot about the Chapter 1 quiz, please still finish it. I haven't gone over any answers for it yet, but you don't want to get behind on this stuff. A lot more Project Zeros came in. So yeah, I tried to get them graded for you guys early, but we'll work on that. Okay? Great, yeah, yep, study session at noon today. Perfect. So you guys go, you can practice some stuff, chat together, do some group studying, group tutor stuff, and then you can even get yourself an extra point on the quiz when I get that posted. Okay? So you guys take care. I will see you next week then. If you have questions, I'll be around for office hours today. You hang on a Discord, or you can always message me somehow. You got all my contact info, and I'll be in touch. Okay? You guys have a good one.